Okay, guys, listen. This is lesson 8, 1-8. This is the first example that you have to understand with this. Here's what you need to know before we get done with this video. How can you use powers of 10, which we are very familiar with because we've been working with them a lot? How can you use a power of 10 to help you estimate how big or how small a number is? Now, we are going to talk about very large numbers and very small numbers. And because of the fact we're using very large and very small numbers, that is why we use scientific notation, because scientific notation is an easier form of a number to use when you're doing something that's really big or really small. So let's take a look at the video here and let's make sure we understand everything that we need to do. Please take notes on this. Okay, I'm going to talk to you a little bit here. I'm going to tell you what to write down. Make sure you write it down and make sure you understand this.
When would you use a power of 10 to estimate a quantity? Think about this question during the lesson. Janelle is comparing the estimated populations of Japan and China. The estimated population of Japan is 126,818,019. Here's the estimated population of China. How can Janelle compare the two populations more easily? You can estimate large quantities and write them in a format that is easier to compare. Janelle knows the populations of China and Japan. Why might she want to estimate the population of a country?
So guys, here's what they're telling you here. We need to estimate some numbers in this world. We don't need to be perfect on some things. The reason that we're estimating the populations of China and the population of Japan, populations change all the time. Remember, there's people that are born every day and there's people that unfortunately pass away every day. And when that happens, the population of our countries, they fluctuate so much that we really can't get a perfect answer to that. So we estimate them. And as you can see, these two numbers that we're looking at in these populations of China and population of Japan, they're pretty big numbers. So when you take a look at these pretty big numbers, we're going to show you a nice, easy way that we can very quickly compare those two.
The population is constantly changing, so it makes sense to work with an estimated quantity. To begin, estimate each population by rounding to the greatest place value. The population of China rounds to 1 billion.
Hey guys, when they're talking about the greatest place value, they're talking about this right here. That's the leading number, the leading digit over on the left. So we know our first number is either going to be a 1, or if this 4 tells it to go up, it could be a 2. But remember, 4 and below, let it go. 5 and above, give it a shove. So in this case right here, since the number to the right of it is a 4, that is going to leave our number 1 as a 1. Okay, and if we jump over here and take a look at the population of Japan, again, our leading number is 1. The digit that is next to that leading digit is a 2. The 2 is telling that 1 to stay the same, so it remains a 1 as well.
And Japan's population rounds to 100 million. How do you determine whether to round the initial place value up or down?
So we've already said this, guys. In order to round this up or down, we always look at the number that is next to the leading digit. In population of China, it's the 4. In the population of Japan, it's the 2. Both of these round or stay at a 1 when we do any type of rounding.
Place value to the right of the initial place value. Round up if the number is 5 or greater. The initial number does not change if the number to the right of the initial place value is less than 5.
So remember, 4 or below, let it go. 5 and above, give it a shove. Okay, here's our little activity. We don't need to do that one. We'll go back to our video here.
Janelle can write each number as a single digit times a power of 10. She can count the zeros to determine the power of 10. 1 billion has 9 zeros, so it can be expressed as 1 times 10 to the power of 9. There are 8 zeros in 100 million. 1 times 10 to the power of 8.
Now, guys, here's what I want you to really understand about this. This 1 is just coming from the number that is here. It is the leading digit. That's where it comes from. So your first factor is always going to come from these leading digits out here. This second factor, 10 to the ninth power, well, we know that as a power of 10. We've learned this. If you look at this number, it's got 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. If it's got 9 zeros, that means it's 1 times 10 to the ninth power. This number over here has 1, 2, 3, 4, 5, 6, 7, 8. So it's got 8 zeros. So therefore, we have 10 to the eighth power. And what I really want you to look at here is this. I know these numbers match. I know this is a 1 and this is a 1. But guys, when you're comparing these two things, we can compare this one right here, 10 to the ninth power and 10 to the eighth power. Which one of those is greater? Okay, obviously 10 to the ninth power is greater. So that makes it very, very quick to see which one of these two numbers is the larger number. We don't have to be perfect. We're not adding or subtracting anything. We just want to know which one's bigger. This power of 10 right away tells us that the population of China is greater than the population of Japan.
Janelle's second step is to compare the estimated values. Which symbol correctly completes the statement?
So
Select your answer.
10 to the ninth power is obviously greater than 10 to the eighth power.
10 to the power of 9 is greater than 10 to the power of 8. So 1 times 10 to the power of 9 is greater than 1 times 10 to the power of 8. That's how Janelle can use estimates with powers of 10 to compare the populations more easily.
Now, one of the things that I want to make sure you guys know as well is this. See this 1 right here and the 1 right here? Yes, they were both the 1 this time. But even if this over here was a 2 or a 3 or an 8 or a 9, any digit, this number on this side would still be larger because it is one place value bigger. Okay, remember, this is actually talking about the billions place, and this is talking about the 100 millions place. And no matter how many 100 millions we have, it's still not going to be as much as a billion. That's what's important about the powers of 10.